In this video, we're going to be talking about one-step equations. So here we have some equations, and I'll make a little lines here to separate the problems. Let's take a look at the first equation. So if reading it out, we got x plus 3 equals 9. Okay, so we want to think about the variable as sort of like a question mark, or my unknown. So we have some number out there, that when I add 3 to that number, that equals 9. So what number plus 3 will equal 9? So you can say, oh, well, 6 plus 3 equals 9, so x has to equal 6, which is correct, and it's a good way to think about it. But let's say that didn't jump out at us, and we're kind of confused on what x would be. The algebraic way of doing this would be to isolate the x. You want to get the x by itself. So on this one, I need to get rid of the positive 3. So to get rid of a positive 3, I'm going to subtract 3. So you want to zero it out. But when you subtract 3 from the left side of the equation, you need to subtract 3 from the right side of the equation as well. It's kind of like a balance. If you take 3 pounds off the left side, you take 3 pounds off the right side. Okay, so let's work this out. So the positive 3 and the negative 3, they're going to zero out. So all you're left on the left side is an x. And then on the right side of the equal sign, I have 9 minus 3, which is going to give me 6, which is what we said at the start, x equals 6. So basically all these on this slide are pretty much going to be all the same. You want to get rid of the number that's with the variable, such like that 5 and that 6. So when we look at the second one, you got to get rid of that 5. Let's subtract 5. And we got to subtract 5 from both sides. The 5s are going to cancel, so the left side I have an a. 10 minus 5 will give me 5. So a equals 5 for the second one. The third one here, you need to get rid of that 6, isolate the variable, get the variable by itself, so subtract 6 from both sides. The 6's are going to cancel. I have an x on the left side. Negative 3 minus 6 will give me a negative 9, so x equals negative 9. These problems here look a little different than the ones we did in the previous slide, but it still follows the same principle. You notice that in all three there is a variable. There's that letter. So we want to isolate that variable. If we look at the first one, you want to get that x by itself, so we need to get rid of that 4. So it's a positive 4, and to get rid of it, we're just going to subtract 4. Now we subtracted 4 on the left side of the equal sign. We are going to subtract 4 on the right side as well. These 4's will cancel. I have an x on the left side. 30 minus 4 will give me a 26. So 4 plus some number is going to give me 30. Well, 4 plus 26 gives me that 30. The next example here, isolate the a. I need to get rid of the negative 5. So when you have a negative number, to get rid of it, we're just going to add 5. So just think about doing the opposite. Those will cancel. I have an a on the left side, and I have a 7 on the right side. So a equals 7. And the last one, I got to get that x by itself, so we need to subtract 4. So we subtracted 4 on the right side of the equal sign. I need to subtract 4 on the left side, too. So these 4's will cancel. 3 minus 4 will give me a negative 1. And that equals x, or just x equals negative 1. All right, so a few more problems here. And something that I didn't mention before on the previous slides is that these are called one-step equations because, well, basically what you're doing is you're doing one step. You're either adding or subtracting something to both sides. So that's what they mean by one step. And a few different examples here. Let's take a look at the first one. Again, you want to isolate the variable, get the x by itself. So for this one, let's add 5 to both sides. Okay, when we have that subtraction, we have to add to get rid of it. Okay, so the 5's will cancel. I just have an x on the left side, and that equals 15. So x equals 15. 15 minus 5 gives me 10. Next one here, get the x, isolate that. So we're going to add 3 on both sides. So the 3's are going to cancel. I have an x on the left side, and negative 2 plus 3 will give me a 1. x equals 1. Next one here, get rid of that 4, isolate the variable, so we're going to add 4 on both sides. So the 4's will cancel, x on the left side, and 3 plus 4 will give me a 7. So some different scenarios that you might see, just a few more examples. We look at the first one here, we got to get that a by itself, get rid of that negative 3 by adding 3 on both sides. Those cancel. I have an a on the left side, and that equals 10. Next one here, isolate the x. So we are going to get rid of the negative 2 by adding 2 on both sides. So the 2's will cancel. I have x on the right side and a 7 on the left side, so x equals 7. This next one here, get the x by itself by adding 4 on both sides. These guys will cancel. I have an x on the right side, 10 on the left, x equals 10. Now these are some problems where we're going to be doing some division. So we talked about adding and subtracting one step, and these next few slides are going to be about multiplying and dividing one step. So if we look at the first example, kind of breaking it down, I have 4x, so 4 times an x, or 4 times an unknown, or some number in the world, equals 12. So kind of think to ourselves, well, 4 times what number is going to equal 12? Well, that's just 3, because 4 times 3 gives me 12. So x equals 3, which is correct. Now the algebraic way thinking about this is, it's the same principle. You want to isolate the x, you want to get the x by itself. So we need to get rid of the 4. Well, what is the 4 doing to the x? It's multiplying. So the opposite of multiplying is division. So to get rid of that 4, we're going to do the opposite. We're going to divide by 4 on both sides. And what's going to happen is that the 4's are going to cancel. I have x on the left side, and that equals 12 divided by 4, which gives me a 3, which is what we originally said. The next one here, I've got to get the x by itself, so let's divide by 2 on each side. The 2's are going to cancel, so the numbers like right here, like the 4's, and these ones right here are always going to cancel. So I just have an x on the left side, and that equals 8 divided by 2, which gives me 4. Next one here, got to get the x by itself. Let's divide by 5 on both sides. So once again, these 5's are going to cancel. Whatever's in front of the x will just cancel out. X on the left, 25 divided by 5 will give me a 5. So here we have some problems where they're one step and we are going to divide, but we're going to deal with negative numbers here. So what happens when we have those negatives there? So the first equation here, again, you got to get that x by itself. So we're going to divide by 4. That's the same. So the 4 is going to cancel. And then what is negative 12 divided by 4? So whenever you're multiplying or dividing, when one of them's negative, one of them's positive, your answer is always going to be negative. So that's just going to be a negative 3. So if you look back to the original equation, 4 times some number, well, 4 times negative 3, will give me that 12. Next one right here, I have negative 3 times a equals 12. So you want to isolate the a, and you're going to divide by a negative 3. You're going to divide by the number and the sign with it. So divide by negative 3 on both sides. These are going to cancel. I got an a equals negative 4. This next one here, get rid of that negative 5, isolate the variable. So divide by negative 5. Cancel out. X equals negative 25 divided by a negative 5. When you have two negatives, when you're multiplying and dividing, it's just going to make it positive. So a positive 5 for that one. So these are one-step equations where, and if I kind of read out the first one, I have an x divided by 2 equals 8. So what happens when I have a number that's dividing the variable? So to get rid of a number that's dividing the variable, all we need to do is multiply by 2. So if you look at the first one, once again, x divided by 2 equals 8. I need to get rid of that 2. I need to get the x by itself. So what I'm going to do is I'm going to multiply by 2 on both sides. The 2's are going to cancel out because multiplying and dividing cancel each other out. I have an x on the left side, and that equals 8 times 2, which is 16. The second one here, a divided by 2. I need to get rid of that 2 to get the variable by itself, so let's multiply by 2 on both sides. The 2's will cancel. I have an a equals 16 times 2, which gives me 32. The next one here, get the x by itself by getting rid of the 7, so let's multiply by 7 on both sides. The 7's will cancel. I have an x on the right. 7 times 3 gives me a 21, so x equals 21. Alright, so continue on with the idea of a variable being divided by a number. We'll take a look at these problems. And you notice that these, in front of the variable and the number that's dividing, there's a negative. So what's going to happen when we have a negative in front? So looking at the first one, same idea. I want to get the, in this case, the j by itself. So I need to get rid of both the 3 and the negative. So what you're going to do on these is you're going to multiply, like we did on the previous slide, by a 3 to get rid of the 3, but by negative 3 to get rid of that negative. So all we're doing on this slide is just multiplying by a negative number. Because the negative will cancel out with this negative, this 3 will cancel out with that 3, but when I multiply by negative 3, I gotta do that on this side too. I forgot that step. So this junk all goes away. I have a j equals, and whatever 2 times negative 3 is, and that'll give me a negative 6. So the next one, I need to get rid of the 2 and the negative, so let's just multiply by a negative 2 on both sides. So the negatives will go away, the 2's will go away. I just have an x on the left side, and that equals 4 times negative 2, which gives me negative 8. Next one here, I need to get rid of the 3 and the negative, so let's multiply by a negative 3. Okay, so all the negatives and the 3's will cancel out. Forgot to multiply by negative 3 on the left side. So I have a b on the right, and that equals whatever 9 times negative 3 is, and that'll be a negative 27. So b equals negative 27. One last type of problem that I'm going to look at for this video. We have no negative in front of the variable and the number that's dividing it, but the number that it equals is negative. So what happens when we get here? So same idea. On the first one, get the x by itself by multiplying by 3 on both sides. I don't need to worry about the negative because the negative is on the other side. I don't need it to cancel out. But these 3's will cancel. I have an x on the left side. That equals a negative 15 on the right. For the second one, multiply by 2 on both sides. X is going to equal negative 16. Multiplying negative 8 and 2 together. And the last one, isolate the x, get rid of that 2, multiply by 2 on both sides. The 2's will cancel. And I have x on the right, and 2 times negative 4, negative 8. So x equals negative 8.